There you go.
Thank you. Sorry
You
about
should be
that.
the host now.
Yep, I can. Yeah, thank you. Okay. So what I was talking about is this microservices. Okay. So I was just mentioning that different services work together independently. Okay. So what are the important parts of it? That single responsibility. Every service has one responsibility. Okay. It is business driven. So one service has one particular task to do. And another important part is it is technology agnostic. So if you want to develop consumer service on Python Node.js, go ahead and do it. You want to develop order services using Java Spring, go ahead and do it, right? So it becomes technology agnostic. So depending on whichever way you want to deploy, whichever way you want to run, you can do that, okay? And it is like autonomous deployment. So let's say that I want to have my user management service updated. Okay, I can do that independently. I don't have to take the complete application down, right? So he's Troy was just mentioning that they are not like a single point of failure. Everything is a smaller independent. Okay, and this also brings the resilience because every unit is independent, every unit is deployed, updated independently, every service is built on its own technology architecture. They all are connected with APIs. Okay, so these are some of the benefits of microservices. Any questions on this? So what will be happening is when we are going to use Docker for deployment, we will not be deploying the whole application. We will actually be deploying the services. Every service will have its own function, its own little function. Okay. Generally, in real life, it can be possible that multiple services are just part of one application. But in ideal scenario, depending on the size and scale of your business, you will be running independent services for each one of them. Okay. So this is the concepts. Okay. So as I was saying, this is another example, okay, of how applications are created in microservices. Is that, let's say this is an e-commerce application. So user can come through website, user can come through mobile app, user makes requests through API gateway, and those requests go to different microservices. Product or cart, checkout, all of these are independent microservices. Okay. There is like generally the chances that databases will be different, but it is also possible that the database server is still the same. Okay. You just have different databases. Even sometimes it could be possible that on the same databases, you are still running multiple microservices. Okay. We just talked about already the benefits that scalability is there, flexibility is there. You can deploy on any way that you want. Isolation of the issues and fault. If this service is down, let's say pricing is not working, no problem. I can still see the product. Okay. Checkout is not working, no problem. I can still place the order and pay later, right? So these are the different options of microservices provides. Though there is some challenge as well, which Docker will try to address. And challenges are like you have increased complexity. Okay. So the way how complexity increases is that the moment you have multiple services, the way, for example, you just broke down the whole application in different smaller services, they become difficult to manage. They become difficult to manage and address and all. So these challenges will be there. Okay. So this is like network overhead will increase because everything is running in separate servers. So their communication will become more frequent. So for that reason, network bandwidth will increase. Data management will become complex. Okay. Operational overhead will increase. Okay. Because you had to care about only the security of this service now. You have to care about security of this, security of this, security of this. You want to do CI/CD, you have to do CI/CD for all of them separately, right? So these are some of the challenges with microservices, but the benefits that they provide still outweighs all the problems that we generally the challenges we can get. Okay. So this is how a diagrammatic comparison of a monolithic application versus microservices. So monolithic application is like this, very simple. You have one application, two application, all of them. The whole business logic is on one project. You have database layer, access layer, API layer, you can say, and the database. So everything is part of just one code base. Okay. Microservices run in a different way. You break down all the application in a smaller chunks. Okay. So here is a quick table comparing all of them. What is monolithic and what is microservices? Any questions? Okay.
No questions at this time, but I will, I'm sure, as we dive in.
Sure, perfect. Yeah, thank you. Okay. So these are some of the things that you generally have to, take care when you are building microservices is that you have to have a version control. You have to use Git, GitHub, GitLab, whatever version control you use, you have to use that. You should use CI/CD so that you can automate all the build and deployment process, right? We have done CI/CD previously, right? One of the lesson I was teaching on CI/CD of Terraform, CI/CD of Ansible. Once we learn Docker, we will be doing CI/CD of Docker. Then once we learn Kubernetes, we'll be doing CI/CD of Kubernetes, right? We have done testing, right? Unit testing, we have done security testing, we have done Sonar QA scan. So all of these things you have to do separately for each project. So this is very important part. So if you are deploying an application through microservices, and microservices means generally that you will be using Docker for deployment, you have to take care of this. Okay. Testing to version control, to CI/CD, to security, everything. Okay, please let me know if there is any question because I am just making a quick revision of these concepts. You will have the link to read already if you want. Otherwise, I will continue. Okay.
Chandra, so all we really want is to understand that these microservices or like how they're implemented or the theory behind the implementation, but not necessarily more than that. It's just understanding that that's a concept that exists and Docker is going to make use of that, but nothing more, or do we need to like dig deeper than that?
Not really. I think, yeah, that's the reason I'm just making a quick run through of this. You don't really need to know all the details of this. This is just like you should know one or two things generally will be helpful in this lesson is, for example, this one, where there is one of the project here is that you will generally be giving a large monolithic application. You should know how you want to break down this. So normally the way problem will be that you join a company, okay, and the company is using monolithic, okay, and they want to move to microservices. They will ask you that, hey, Jose, you want to go to microservices? How do we do this? So what you will have to do is that based on these business use cases and these features and all, you will break down all the smaller services and units. Once you break down each smaller units, you will have to build this strategy to the CI/CD, version control, all of that. You have to do the scaling and all of that independent for each of these services. Okay. I think apart from this, nothing else you need to know.
Chandra, can I give like just them like a little like how I see it with that?
Sure. Yeah.
Oh no, I was actually going to use that visual that you had up that showed the API and the microservices.
Oh, do you want me to open a particular visual?
Yeah, just that visual, that diagram that you had, because this is kind of how you had another one,
This
one
one?
that shows the API gateway. That will work. Then you have that one. That one's perfect. So this is how I see this. Yeah, I don't know if this will help or hurt, so let me know, Jose. How I see it is like, okay, so your API gateway is just doing nothing. It's an AWS resource that's just kind of like routing, like doing nothing more than like routing these calls to look at those as like different Flask applications. Like, so each one of these microservices, you could write an application that does like, you know, this is like a shopping application that has all of these things in it. And then you could like sit down and write a full stack app. And then you could launch that app without microservices. And it would look like this, except that those 4 things would be smushed into one app that would be launched on, say, like an EC2 instance. And then there would be a database. There could be multiple databases too, but there would just be one application running in like an EC2. And what you see here, the way I look at it, those are all, take the Flask application and break it down into 4 different Flask applications, and then look at them just running separately on different EC2 instances. And then go on the next level. You'll see this when Chandra shows us later. The Docker just takes the place of like the EC2, and it's like those are just going to be Docker containers with an image. And the first one, like the product, that's just going to be an image of your Flask application that's for the product portion. And then you'll have a cart application that you write, and then that will be an image just for that. And you pull those images in and launch them. So does that help at all? Like, you really just look at like Docker images as you're going to take a Flask application or other applications and put it and use Docker to launch it. Does that help? If it doesn't, I'm sorry.
No, yeah, it does help. I think that's cool. It's a good way to see it too visually, like, or at least for us, what we're familiar with, that makes sense.
Yeah, just trying to tying it back into like what you guys know, and you guys do know like Flask apps. It could be a Django app, it could be a React app. I'm saying Flask app. It could be any sort of like software that you develop, application that you can develop. It's just being broken down, which is good, right? We already know that as software developers, and you're supposed to break things down into smaller chunks because it's easier to test and fix and replace and run in isolation. But yeah, so I just wanted to say that because I feel like that ties it to what you guys might know.
100%.
And the concept of microservices is not Docker specific, right? Microservice is just an architectural format for modern application writing that has tended to trend in this direction. And ironically, there is a slight backwards trend towards monolithic in industry, which is interesting. But at least for the last 10 plus years, microservices has been the new way to do it, and Docker and Kubernetes has risen up to really answer. Oh, and and of course Ansible really helps here too. But yeah, it's not specific to Docker.
Totally. I think that is very valid and important point, Troy, that you just mentioned. And thank you, Chad, for giving your perspective of explanation. And I think beautifully, I think that Troy, the way you were saying that Docker has become de facto a standard way of doing it, but Docker is not I think microservices way of doing it. It's not the only way of doing it. Even if you take all of this code and deploy this in a smaller servers in different way, there is still microservices. The overall idea behind microservices is that you take the big piece of the application and you make them a smaller for these benefits: scalability, flexibility, fault isolation, technology diversity. All of these benefits you get, but that does have nothing to that does have to be like Docker only. Okay, Docker does provide the easiest way of getting all these benefits, and that's why, as Troy was saying, there is like almost like de facto standard. But there is obviously a backward trend. People are saying that, and what I was just mentioning here is that the challenges with this. So microservices are good, but obviously they have challenges. Like it increases the complexity. So for example, let's say there is a startup, they're just building the product. If they start building all the microservices and they start doing CI/CD of each of them, deploying each of them in different Docker container, that is going to increase cost, time, complexity, and everything. So generally, idea is going on now is that if you are very small, build a small code base and get the whole thing working. Once you scale, then take it out into smaller pieces and build microservices. Troy, did I feel what you were saying?
Oh yeah, very much. Yeah. And there's some competitors to this containerization technology, right? Docker is containerizing, and there are some other products that do the same thing. Docker is just the de facto sort of front runner.
Exactly, 100%. Yeah. So I think you're totally correct. Okay. So I think Docker is not like the only Docker can do this, but I think there are ways. For example, I should have a lesson on this alternative to Docker. I'm not sure if there is one, but I will definitely send you. So there are some products which are kind of the replacement for this, but Docker is kind of still the de facto standard. Okay. I would like to quickly add on what Jose was asking is like, how do you see and look on this? So one of the example, probably a use case I'm going to show you, Jose, and that use case is this kind of the real life example of the use case of learning microservices. Okay. So this is a use case. Okay. And this is just the dummy use case I have built based on a real application. So one of the lesson I was building that was like intensive on microservices. So I wrote this one. So this is kind of a e-commerce application, EcoCheck, and they are having the following issues. They have scalability issues, they have slow deployment cycle, they are locked in a particular technology. For example, they are running on Python, but they want to include chatbot service in their application. Python is not good for chatbot kinds of application. Generally, people prefer Node.js for that. So they are having difficulty in that. So because of these issues, they have hired an engineer who will help them to move to microservices. And they asked me, okay, what is the approach? How do we do it? And this is the approach the engineer has provided, is that we will be doing this thing, we will be using containerization, we will be doing orchestration, then we will do API gateway, which Chad was mentioning, and we will use a service mesh, we will learn in Kubernetes, and we will do all the load balancing and everything. We will do all the monitoring and all, and then we will do the gradual migration. We will not take the complete application down. We'll take it step by step, service by service. Okay. And the case study says that this was the challenge the company had, EcoCheck. Then this is the approach which was provided by the engineering team. And once they were able to do it successfully, these are the benefits they got. They got high scalability, they were able to deploy faster, and they got like a good fault isolation. Even if one of the services is down, other service is still running. So this is probably, I think, one of the way how this learning can help. Jose, if you want, I will send it for everyone. You can probably have a look on these case studies. All right. Okay. So thank you everyone for filling the gap in my explanation. Meanwhile, I will continue. I will just talk about one last thing before we move from microservices. A very important part and concept in microservices is statelessness. I believe you already may be knowing it, but otherwise I will still quickly talk about it. And by the way, am I just repeating myself? Is it like you already know all of this? I'm just no need to go in this. Is it so?
I like you going through it.
Likewise.
Yeah, okay, thank you. Yeah, perfect. So yeah, so I will, you have the link. You can always study further. But meanwhile, I will just do a quick revision still. Very important concept in microservices is concept of a statelessness. Okay. So what is a stateful application? Okay, as simple as that, application which maintains a particular session, a particular state. Okay, so for example, when you are, let's say, applying, let's say you want to create a bank account and you are filling the details. That is one session. Okay, you have filled half of the details. You are halfway through the session. Your half of the state is ready, half of the is yet to be finished. Okay. So if, let's say, server restarts, you lose the data. Why? Because the state was stored in a particular session in temporary storage. Okay. So that is not good actually for microservices. Why it is not good? Because if, let's say, the server restarts, you lose the whole data. Okay. On the other side, statelessness means that we will not create any particular session. We will not maintain a half record data in temporary storage anywhere. We will take the data, process it, and store it. Okay. So for example, let's say you want to build a chat application. Okay. So the moment you send a message, okay, the message is sent using REST API and it is sent to the user. Okay. And if the user replies, that message is stored in probably a storage. Okay. So this is kind of a session based. If let's say the session breaks, communication break, you have to restart and build the session again. Okay. So in stateless applications, you don't have a state stored on a particular machine, on a particular storage. The application is deployed across different servers, and whenever you make a request, it goes to any particular server. It can go to any particular container running, and it can serve you the data. So benefit of that is you can now build application which is microservices based. You don't have to worry about a server, and now you can achieve infrastructure as code. Because let's say you want to have some issues, you're having some issues in server, you shut down the server, you create a new server. Why you can do that? Because there is no session stored on a server. Every session which has to be stored at all, let's say chatbot application is, you want to store the session, you will store that in let's say elastic cache in Redis or something. Okay. So but you will not leave that on temporary session or in a memory. Okay. You will store this somewhere in the storage. Okay. So this is the important part in this that if you want to Dockerize any application, you have to make sure that those independent services have no state dependencies. Okay. What do I mean here? So for example, in this diagram, if let's say a user is placing order and the order will then go to checkout, checkout will go to payment. It's not that the order and checkout are interdependent. Order user places, store in the DB. User is now going for checkout, store in DB. User is now making the payment, store in DB. Okay, making sense? So you have now removed the state and stored every state somewhere in temporary database, and next service then processes from that particular database. Does it make sense? Okay, so for example, you can have a look on this, that how do you build a stateless application? So even if you have to, the way I was telling, you will take the state and store it in a database. For example, elastic cache, you will store it there. Okay. Now you want to do load balancing, you want to have multiple servers, all of that will still work. Okay. So just go through this, read about it. It's a bit of theoretical knowledge, and only probably I believe it will be useful if you are a bit senior position in the organization. But it could be possible that you join an organization and they are really into migration phase. They can say that, okay, can you give us a plan? And then we can probably continue from your plan. Okay, makes sense? Any questions? All right, okay. So with this knowledge in microservices, and another thing that you need to know is 3-tier application, okay? I know we are almost an hour, so I will quickly make a quick explanation about 3-tier application, okay? And then we will start Docker, okay? So what you need to know about 3-tier application is that this is how a normal application looks like, okay? Very, very simple explanation of a diagram of, let's say, this one. Yeah. So this image is a very simple diagram of a 3-tier application. And the way how it is, you have a client, and the client is kind of your front end. Okay, this is where the users, okay, public interacts with the application. Okay, for example, this Zoom app, this is the client side. Okay, the app that you use, that is the client side. Okay, the place where you fill the form, that is client side. And what goes behind the scene, whenever you press submit button, then whatever data goes behind, that system is the backend. Okay, that is a server that is the logic layer, the business layer. Okay, this is where all the processing will happen. Let's say you apply for admission in code Platoon and you are below 21, probably you will not get accepted. Okay. The reason is I think there is condition probably. Okay. So this kind of condition goes in. And the third thing is your database. So this is where users interact. This is where the business logic sits, and this is where data is stored. Data is not stored here. Okay. We generally feel data is on my server, No, data is on your server, but on your database server, not on your application server. Okay. So this is your front end, this is your back end, this is your database. Okay. A typical 3-tier architecture. You can have multiple. You can have SQS, you can have SNS and all in this. You can have RabbitMQs, you can have multiple other layers can possible. Cache layers would come, but they all are still a bit more diverse family within 3-tier or 4-tier application architecture. Okay. Do you understand this? Any questions?
No.
Yep, please. Yes.
Oh, I understand it. No questions at this time.
Okay. All right. Yeah. So for example, in your to-do list application, this is your backend layer. Okay. This is what I'm talking about, the server, the backend. This is your backend. Okay. And this thing is your front end. Okay. So when we used to open this application, okay, this is your front end. When you submit data, this goes to your backend. And this backend will then store the data in your database, and your database probably could be somewhere. For example, this database is probably on Docker. It is using Docker for this. So this is your database layer. This database I was talking about. Okay. All right. I believe we have used this many times, so no need to go more further in details. But this is just kind of a quick revision on that. Okay. All right. So with these two prerequisites, we are now ready to start with our lesson on Docker. Okay. Now we are an hour, so we will go for 10 minutes break. Returning 10 minutes break, we will learn about Docker, why Docker came, and this is like a very beautiful explanation given by that company, Docker itself. Okay. All right. See you in 10. All right. Okay. So we will have a quick installation of Docker before we get into the lesson. So can someone confirm, can everyone confirm me if you have Docker installed in your system or not? So the way how you can check is you have to write Docker minus version probably. Yeah, and you can see the version you have. Anyone who doesn't have Docker installed in the system? Okay, so I think everyone has it installed. Okay, perfect. Okay, so if Docker is installed, then I think so. This lesson on installation. If you don't have it installed, then this is the link for Mac, Windows, and Linux. For Linux, I think you can. Yeah, this is the script. Using this script, you can install Docker easily on your Linux machine. This is for Ubuntu machine. This is for Amazon Linux machine. Okay. So let's say you are running Docker not on your machine, but on the server. You can just use this script, and this script will install it for you. Okay. All right. So if Docker is installed, then I think we can just start with the lesson then. If you don't have it, please go ahead with this link and either use this script or use this link and install Docker based on this link. All right. So I think some of these concepts are, I think, a bit trivial. So probably I won't be spending a lot of time in this, but I will try to still cover most of them while being still in the flow. Okay, so we will be talking about Docker now proper in details. So, going back to the system, if you see the IT landscape is changing in the way that you earlier did not have cloud, now you have cloud. Okay. Earlier, you did not have DevOps because you do not have cloud and deployment. You have one application monolithic, you take the application, deploy it. Application is changing. You earlier had monolithic, now you have microservices, right? So for that reason, this is changing very frequently, very in a very big way. And this is not something new. It is happening from almost like at least from 5-6 years, more, even more than that. This drastic change is coming, okay? And a big reason for this push is cloud. So almost 10 years back, when cloud became like a go-to thing for most of the companies, still not everyone is there, but at least I believe 30-40% of the workload in the internet is on cloud now, okay? So they predict that this will increase. By 2028, almost 70% of the workload will move to cloud, okay? And if you want to move to cloud, you want to avoid the vendor lock, so that if, let's say, you want to build on AWS, if you want to change from AWS to cloud, you can still do that someday, okay? So this rapid change that we are having a look on, from monolithic and slow changing to large servers. Now thing is that monolithic has become microservices. We used to update application very slowly. For example, one update in 2 months, 3 months, right? Now you get updates daily. If you see an issue today in the morning, in afternoon, issue is fixed, okay? Earlier, you had very large servers, one server with 16 gigs of RAM. Now you have probably 4 servers with 4 gigs of RAM, still 16 gigs, but you have more servers, okay? So the problem because of that is happening is that you have lot many ways of deployment, and you have lot many applications, right? You have many types of applications, correct? We have front end, we have back end, we have a user database, we have rabbit queues, you have API endpoints, you have analytics application. There are dozens and dozens of type of applications, right? And at the same time, there are dozens of ways of deployment. You can deploy, first of all, you run it on your machine, local machine. Then you put this in testing, QA server, then you put this in development, then you put this in probably cloud. Let's say you are bank or something, you are not comfortable with cloud, you put this in your own data center. You see, you have hundreds of variations of application, and you have dozens of variations of the way how applications are deployed, okay? And that situation is bringing this problem, the complexity, is that we want to run everything on every device, isn't it? I want to run database on my machine. I want to run front end as well. I want to run Flask as well. I want to run Java as well. Everything I want to run. I want to run it on my machine as well. I want to run it on server as well. I want to run on my colleague server as well. I want to run it on data center and cloud, everywhere I want to run. And that is a problem, right? Because it's all different machine. It is all different types of applications. And because of this problem, the complexity has increased. And this is increasing continuously. As more applications are coming, as smaller applications are becoming, as faster the competition is becoming, there is a huge demand for change. And this situation, if you feel, is very similar to this. And this is the example, by the way, that was used by this company Docker. Okay, I will talk about Docker in a moment. And the example is that, let's say you want to ship something from US to India, okay? You want to ship, let's say, car, you want to say, let's say, ship servers, you want to ship, let's say, oil. And at the same time, let's say you want to import some of the things. You want to import grains, you want to import, let's say, hardwares, you want to import, let's say, many other things, clothes and all. These all items are shipped in very different ways. And they all bring challenge. How can you ship car as well and oil as well? How can you ship clothes as well and grains as well? Right? You see the problem? All these things are very similar to this, right? So the problem that we had here is very similar to this problem, isn't it? Multiple applications, multiple ways of deployment, multiple things to ship, multiple ways of shipping. And this is the
over-delivering and under-promising.
sorry.
It's politics and many other things.
Sorry about that. Okay. I think I'm back on a screen. Okay. So I will continue from where I was, and recording is still going on, everyone. So I was talking about this. Okay. And so this problem is very similar to this. How do we ship multiple items in multiple ways of shipment? And for this reason, our forefathers came with this concept of container. You want to ship anything from car to clothes to musical instruments to needles to books, anything. You put everything inside this container, and you can now ship container using ships, using train, using bus, truck, whatever you want, right? So this is very similar, right? So what we did for shipping, the same thing we want to do for application. And that container, that shipment container is Docker for us. So you want to ship anything, you want to run this on machine, on server, on data center, you put your application in the container and just ship it. Right? So beautiful it is, right? Whenever I see this, I feel very much amazed how these people came up with this analogy and this concept. So beautiful it is. So simple, so beautiful. That if you can't ship, put in container. You can't run, put it in container. And that container, ladies and gentlemen, that is called Docker. So whatever you want to put, just put this inside a container and just run this. Okay? So this matrix of deployment is solved. So you want to run any type of application, you just put this in the Docker container. You can run Unicorn application class. You can run Redis application. You can run Postgres database, MySQL database, anything you want to run. Just put that inside Docker. Now you can run this on your machine, on your server, anywhere you want. Okay, so this is the approach of application modernization, that you take the application and you put them in different containers. Okay, so this is the application, and you have taken making this a smaller, and now you are coming from full stack bootcamp, so you know what is microservices. We already talked about it. What is 12-factor application? If you don't know, please Google about it. You know the applications are now microservices, so you can deploy them separately. Okay, so now coming back to microservices, now you can take all of these smaller services and you want to run it anywhere, you just put that inside a container. And now you can ship it anywhere you want. Okay, make sense? The advantages you get, you can package the way you want, you can run the way you want, you can install the way you want. Another benefit you get, you can do the CI/CD, you can do SonarQube testing, you can do unit testing, you can do deployment the way you want. Make sense, everyone? Any question?
Quick question. When I think of an application and runtime, I also think of the kernel that the OS, the kernel that it's running on, and that state that it creates at runtime, the dependencies that application needs. Of the required things to run an application like the OS, the kernel, what is Docker hosting or providing that allows you to containerize various coding, stacks, tech stacks, and make them, oh, the word just slipped my mind, but yep, okay.
I
Thanks.
got your point. I mean, it makes them easy for you to run, deploy, run anywhere, easy to package, right? Yeah, definitely. So try that is a very beautiful question. And I would be talking about this in details when comparing virtual machines with containers. But since you have asked, I will quickly talk about it now. Okay, So Troy's question was, what does Docker do? What is it? How is it doing it? I mean, the application is running so beautifully, easily. How does it do? See, so the most important part you should know is you always have a server. Okay, Docker is not replacement of your machine. You have a server which has RAM, which has processor, okay, which has storage. What Docker does is that generally what you have is this is your infrastructure. Okay, inside your infrastructure, you have directly the operating systems. Okay, you have the operating system. Let me see if I have another diagram more suitable. I don't. Okay, so you have infrastructure. On top of that, don't worry about hypervisor right now. You have machine, you have operating system, you have Windows, you have Ubuntu, whatever. On Windows, let's say you want to on, let's say Mac, I have. On my machine, I have Mac installed. Mac, I want to run, let's say Flask app. So I install Flask, that becomes a library. And I run it, my application to-do list app is running, right? Very simple. Server, OS, library, and application. Okay. Now what Docker does is, it does a very beautiful thing. It has its own runtime. Okay. And that will bring us to talk about Docker architecture. I will talk about Docker architecture in a moment. I should have that somewhere. Docker architecture. Yeah, Docker architecture. What Docker does is, it has something called Docker daemon. Okay. And Docker daemon, what it does is, it will, okay, it will have a virtualized, a smaller version of operating system already. Okay. So what it will do is that it will use the kernel of the OS directly. The biggest part of any machine, any server, any operating system is the kernel, the main code base of the operating system, which is the biggest inside. Okay. So what Docker does is, it encapsulates that. So you will have infrastructure. On top of that, you have your own operating system. Totally fine. What Docker will do is, the kernel that you have in your operating system, it will directly use that kernel here. So you don't need different operating system anymore. Okay. So let's say you want to run to-do list app, you want to run Duoj app, both of them will be using the same kernel now. Okay. Only thing is, Docker will provide isolated environment where you just install the dependencies that you need. Okay. So kernel remains here, and this is where you install the dependency, and this is where your application runs. Okay. So Docker is actually helping you to leverage the same operating system to run your application, instead of you installing different operating system on every time you want to run different application. Okay. Troy, does that make sense?
I think so, yeah. Sort of your universal translator.
I think you can say universal probably gateway. So what it does is that you have the same kernel here. Okay. The kernel remains the same. Okay. This kernel. Okay. It will just help you to use that same kernel using its architecture. That architecture we will talk in a moment. Okay. Yeah. This is where, see, if you want to go in details, this is where, this is how it works actually, Troy. I will come to,
yeah.
Okay, in details.
Yeah, and gateway was good term. That's more apt.
Thank you. Yeah, sure. Yeah, we'll talk about it. Okay, in a moment. When we talk about this, we'll talk about all of that. Okay. Okay. Yeah. So that was a very good question, everyone. Okay. So this is what Docker does. Okay. Now to understand how Docker is functioning, what are the benefits, let's first use Docker. Okay. Then we will appreciate it more. Okay. So let's get back to our lesson. And what we will do is we will do a bit of hands-on. We'll come back to the theory. We'll do a bit of hands-on, come back to the lesson. Okay. So everyone, please open this lesson. Okay. And we will do basic container commands. make sure your Docker is running. You can type like this, Docker version. It will give you all the details. So you can see I am using 2022 build, which is somewhat old. But yeah. Okay. Now we will be doing very, very basic commands, okay, of Docker. I believe you may already be knowing a bit of it, but still I will be showing you this, okay? Okay, so the first one is sudo systemctl status Docker. This will work on your server, okay? Not in this machine, so ignore this. But you can always run this command on server, okay? The second command that you see, okay, everyone running these things with me?
This is supposed to be inside a container or like inside a...
Inside the terminal, just the terminal as of now.
On their local machines, not an EC2 instance.
No. So, I sometimes give these instructions because sometimes the students have issues with Docker. So I tell them that, okay, you can go ahead and run a server to do this. And Troy, did your issue go away on the Docker issue?
Yeah, Eric solved it. Eric and Mika knew what was up, and they guided me. Thanks.
Perfect, thank you. Okay, so we are good then. So you can write Docker help, and you can put that less, and you can see all the options Docker provides. Okay, so you can go and read about it, different types of commands that it supports, and everything is here. Okay. And this is the very basic command that is called Docker run. Okay. So, and the way how Docker works is that if you write run, it will pick a particular image and run this. Okay. What is image? What is container? We will talk about it in more details. Okay. For now, you can just understand that container is just like the not running image is like a not running application. Okay, it's just like a blueprint. It's just like the static application. When you run this, it runs as a container, then it goes into the runtime. Okay, so let's try to run this. You can run Docker run -it. You can write it together. Okay, -it. And you can see it is saying unable to find this image. Okay, locally, so it is pulling this from internet, and the place it is pulling it from, that is called Docker Hub. Okay, we'll talk about this Docker Hub in the next lesson, but for now we'll just continue. Okay, so what it has done is Docker has started Ubuntu container in our machine, and you can see I have gotten inside the container. Okay, inside this is now just like your another Ubuntu machine, another Ubuntu server. Okay, in this terminal you are no more in Mac machine, you are just in Ubuntu server. So for example, you can run here /etc/os/release. You can see you are on Ubuntu server actually, Ubuntu 2024. Where did I get Ubuntu? It is coming from Docker, actually from Docker. Make sense, everyone?
Let me see if so Docker's native OS is Ubuntu?
Not really. It actually depends on what OS you are running. So I'm giving here name Docker run -it Ubuntu. So this is actually running Ubuntu OS. Okay. We will be doing it later. If I write here Nginx, it will run actually Nginx. But you are partially correct that majority of the applications that you will be using, they all are generally based on Ubuntu as the base layer, as the operating system.
Okay, so sort of a configuration option when you're running your Docker or containerizing your app would be choosing. Yeah.
Different OS, yes, totally,
Okay.
yes.
Thank you.
So for example, let's say I don't want to run Ubuntu. I can probably just go here and say that I want to use CentOS. You can use CentOS, no problem. I can use Red Hat. You can use Red Hat. Okay. If you write probably echo $0, this will tell you which place you are. Okay. So this is the shell name you're using. Okay. Right. Where am I probably? You can see you are using it as a root user. Okay. Now this is just your Ubuntu server, as simple as the OS you had. So what you can do is you can go here and you can run these kind of commands. You can update it. You see, this is the same apt update we used to run in EC2 servers.
Okay, and you want us to just go through these commands in our terminal?
Yeah, I think I know you know the result of this. Only thing is if you do it, I think you can just keep following with me. Yeah. The results is I will be showing you. These are just like a hands-on to get practical. You have used this already a bit. I will recommend to do it again. Yeah.
Okay, thanks.
Yeah. Okay. So Chad was just mentioning, and we'll be talking about this, that you can actually mention the different versions as well of the OS you want to use. Okay. So the way how it is hub.this. This is the place where all the images live. Okay. So this is the place where this image is coming from. Okay. This is called Docker Hub. We will be creating an account on this and using this actually in a moment. Okay. So you can see it has multiple versions. For example, it has ARM version, it has AMD version, it has ARM32, 64. Different versions are there. You can see here more. Okay. Okay. Now there is a command called docker ps. Okay. So if you type exit, you will come out of the container. Everyone type exit, you will come out. So for example, you are here. You type exit, you will come out. Now there is very interesting thing here. That is a -i and -t. What is -i and what is -t? So -i means that I want to use Docker in interactive manner. Okay. And -t means timeout. So I don't want to time it out right now. Okay. I want to stay in this. Okay. If you do not give this, what will happen is you will not be able to interact with this. Okay. It has gone. You see? So what happens? Docker container starts and it stops. It starts, it stops. Okay. If you give -t, okay, you will go inside this. Okay. But you cannot interact. You see this? You are not able to interact using this. So why? Because I did not give, and you cannot even give an exit command in this. You'll have to close the terminal actually now because it is not interactive. Okay. So what you will have to do is you have to always give -it. You don't have to give it separately. You can give -it. You can write docker ps. Oh, sorry, I'm already inside. Yeah. Everyone following with me so far?
Well, I got hung up on some of these steps, Chandra, so I'm falling behind.
Oh,
But
okay.
that's
I can wait for you. So essentially, I have run 3 commands actually, Troy, if you want to follow with me now. First command is this. You go inside. Here I was just showing that which OS you are on. This, okay. This just proves that you are on Ubuntu machine now. Okay. Yes, but Eric, you are correct. Okay. That if you want to go inside any container, we will be doing this. Okay. We'll be doing this a lot. You'll be running this like dozens of times daily. You can go inside. And it's just like Ubuntu OS. You can just run this command and it will just update the server for you. As simple as that. Okay, it is just updating the OS for us. Right? Okay, now the next thing is the command called docker ps. You can run with help. Everyone is running with me, these commands. Everyone is following with me. Any questions so far?
how do you get out? Oops, sorry. How do you get out of Docker help?
Docker help. You mean this command, docker help?
Yes.
Oh, this one? Oh, you just press Q.
Q. Okay, thanks.
Yeah.
Chandra, there's some confusion and I'm explaining it, but I want to make sure that I'm even understanding this correctly. So the students want to know when you wouldn't run the IT, and what I said was generally when you're running images that like you've created or whatnot, there's going to be baked in commands that will run the image, and then but you may want to also be inside the box when it runs. But is that an accurate explanation?
I think very close, Chad, and thank you that you had a look on the question for me. And let me open the chat and see it once. Oh, I think this question is from Nika. I think you're probably totally correct. I think there's just one thing. I think a very simple example I would like to give here is when you don't want to run it in interactive mode. And the case is, let's say, you have analytics server, okay? Analytics container is there. You just want to read the data, okay? You don't want to touch and give any commands on this. Let's say you want to run a very critical container, healthcare data or something. You want users to run it, but not play with the data, okay? Even by mistakes, you don't want to do that. So you will just open this in a normal format, okay? And you will just see the outputs there, okay? You will not give commands to it. You will just see the outputs coming from the container. Okay, in read-only mode you want to do. You just want to see the logs or something. Yeah, exactly. You just want to see the outputs and anything. Yeah, exactly. Yeah. So normally this is not the way how you will do. You will always have your safeguards. You'll have the things protected. You will not have the things open, like not anyone can take your container, run it. Even if you are, safer side is you don't run it in interactive mode. Otherwise, I think I can find some more examples to do it. Okay, I think. Okay, Troy, did you come closer with me?
I did, thank you.
Okay, the next command, everyone, is called docker ps. So if you write docker ps, this will tell you status of all the running containers. Okay. So you can see here, there is nothing right now. So there is no container running. Okay. But if you run docker ps -a, everyone please run it with me. Docker ps -a, you will see the output of all the containers you have run so far. And this is something very interesting for everyone to understand what it is. First part is the container ID. That is the container. Every container will get a unique ID. So you can identify the container. Okay. Second thing is called the image. What is the source image? Which image you are running? So the image we were running is, that is Ubuntu image. You see here this one? This is the Ubuntu. Then is the command. So whenever you run this, by default, we will learn about it later when we are actually learning Docker file and all. This is just the command which by default runs. Okay. So this is just the command which has started this that it shows, and this is the created. When was this container created? This is status. Okay. If it exited easily, or if you kind of forced close it. So that is kind of the status. This is just telling time. This is telling ports, which port it was open. So there is no port, so it is just showing blank. And this is the name. It will randomly give a name if you do not provide a name. So every container will have these information with it. Please understand. Let me know if you want me to explain anything. Okay. So Docker ps -a is the way how you can actually see the details of your container. Now there is a command that we are going to run that is called --- name. You call it -- or -- that is your preference. So this -- what it does is it will give a particular name for it. Okay. So instead of you having these random names, you will have the name given by you. Now there is a container called busybox. Okay. So let's talk about busybox. Okay. So busybox is a very popular and demo server. It is a very small, very tiny size. Okay. Used to run something which keeps running. What happens right now is whenever you run Docker Ubuntu, server starts and it stops. You exit, you lose it, right? Let's say I don't give it, it stops, right? Because Docker containers are supposed to do the moment you run it, there is a Docker file we will learn later. It will just execute everything and it will stop. Sometimes you want to get it keep running always. You will be using something called busybox. Okay. So let's use this image busybox, everyone. Everyone with me so far? Please give me a thumbs up if you're following with me. Okay, cool. Thank you. Tristan, are you following with me? Are you with me? Or are you ahead from me?
No, I'm following.
Okay, that is totally fine. Being ahead is always welcome, no problem. Okay. Yeah. Okay, I think, Cass, what I will recommend following now, I have gotten some feedback from some of you that, you do not follow with me, and what happens is lessons keep getting stacked. So yeah, I think, yeah, that is fine. Good. Yeah. So what happens is that from now on itself, what we can do is probably we can take the lecture longer, we can go slower and longer, but everyone follows with me. Okay. So let's run this command. What it is doing, let me type this instead of copying. So you can write Docker run -it. I means interactive, T means timeout. I don't want to timeout. Okay. -- name. And I can give my name, Chandra busybox. Busybox means it will keep running, busy. It will not stop. And this is the name of the image. I will talk about it later. You see, unable to find it locally. So what it is doing is, it is pulling it from internet, from Docker. Now okay, so if you run this, now the problem is, you can see here one thing. If you run the same command again, do you want me to go slower, anyone? I can go slower.
It's fine for me.
Fine. Okay.
The speed you're going is working for me, so.
Okay. So if you run this command 2 times, okay, problem is you will already have a container with this name. How do I know it? You can write docker ps. Oh, sorry, there is nothing running. ps minus a. You see here, Chandra PG box. There is no random name anymore. Nervous Robinson, Loving Blackburn, Youthful Alice. It gives very interesting names. Goofy Dubinsky. Okay, Romantic Booth. That is good. Sleepy Edison. It gives these funny names. But you can give always your own name. Okay. Problem is there is already an image with this name. What you can do is you can run it with another name. So docker run -it minus name Chandra busybox new, and you give this name busybox, and you can see that I have got an inside the container, and this is just the same container, everyone. If I write cat os / release, I think this is the command, right? No, it's not the command. Command is os - release. Okay. Okay, I think it is different flavor of server then. Oh, there is nothing actually in this servers. Okay. etc. Yeah. Okay, this server has everything removed. It doesn't have even that command. Okay, we'll talk about it. Okay, so there are a lot of things which we will be talking. Okay, so some of the things I will just say we'll talk later. So we'll talk about them later. Okay. So now if you see docker ps -a, you will see 2 different containers. Now, okay. There is one more thing I want to talk about, and that is, let's say we want to run a container. Okay, I'm running another container. Okay, docker busybox 3. I'm creating this. Okay, you can create files here. Hello.txt. Okay, vi hi.txt. I can write hi learning docker. Okay, files are here. You see, hi.txt, hello.txt. I will exit. Okay, because I was inside a container, I have come out, file is not here. Where is the file? File is inside the container. Make sense, everyone?
Can I just quickly ask, this busy box is a server. So we have containerized a server, an OS, on top of whatever our host machine is. And now we're playing with it, we're working with it just like it's a real server.
Pretty much, yeah. Yeah. In fact, you will understand it more, you will feel it more when we are using Nginx actually.
Awesome, thank you.
We will have that coming in a moment. Yeah. Yeah, but that's a good observation. So where is my file, everyone? Where did that file go? It is inside this container. Okay. So now I can write Docker, okay, run -it this. No, oh, sorry, I need to write Docker start. Yeah. Docker start. Oh, I can just give this command. Okay. Oh, Docker start. Okay. And you can see my container is running. Okay. Where is my file? File is inside this container. Okay. Are you understanding the concepts? We will be using all of these concepts a lot.
Yes.
Thank you. Now, how do I go inside this container? This is my container. I started it. How do I go inside? So command for that is Docker. I believe the command should be somewhere right here.
It's Docker exec exe.
Yeah. So it is not given here in the doc. Actually, it is. That is called Docker attach. But I will prefer Docker exec generally. Docker exec -it. Again, I want to do in interactive mode. Okay. And then you will write the container name. Thank you, Chad. And then you will tell which command you want to run inside the container. Okay. So let's say I want to go inside bash. So I think I will write bin/bash. Okay, I think it doesn't have bin bash, it has just sh. Yeah. Okay, so you can see now my file is here. Everyone, please do this with me. I will give you 5 minutes of time to follow what I just did. Let me know any questions. I'm here, please do it. What you have to do is you have to start a container, you have to create a file, you have to come out, start the container again, and go inside the container. To go inside the container, this is what the command you write. Chad has also seen the command already, and I'm sending it as well. This is the container name. /bin/sh actually is just like it is telling which shell I want to use. Even if you don't give bin, by default it looks in bin, so it works. But otherwise you should provide bin path. Everyone following with me? Any questions? All of these commands and instructions have been given here. We have followed so far. We will now follow further. Two more minutes, everyone.
Hey Chandra, can you go over the difference between run and start?
Oh yeah, sure. Yeah. Okay. So the thing is that, let's talk about Docker lifecycle actually for that. Let me see which one is the best. Probably this one is the best. Okay. So, and I would be talking about this later anyway, but I think I will talk about now. So the way how Docker works is that it pulls the image from Docker Hub. What is Docker Hub? We'll come to it. Just think it is a remote repository where all the images are stored. Okay. What is the image? It is just a ready-made blueprint which you can start. Okay. Which you can serve. So it pulls the image. Okay. And you, whenever you write Docker run, what it does is it pulls the image if it is not in your machine, and it will start the image. Okay. So when I'm writing Docker run, okay, it will pull as well and it will run as well. If I run Docker pull only, it will only pull the image, and all the images in my machine are visible here, Docker images. Okay. These are all the blueprints in my machine. Okay. When I run this, actually a copy of this code base starts running. Okay. And when I actually, but the copy when it is running, I can stop it. I can run it. Okay. For example, if you see here, BusyBox, it is probably the tiniest image here, 4 MB. What it is doing is, it is right now resting inside my machine. When I run it, Docker run, okay, -IT, minus name, BusyBox4, okay, and then I write BusyBox. A system will first look for image here. If image is not here, then it will pull from Docker Hub. So if you search here BusyBox, this is the BusyBox server which is pulled. Okay. So that is the part of running. Okay. But what is start? Right? Eric, your question was what is the difference between start and run? So when you run this, okay, it will start running here. It is running. So if I write Docker PS, you see, BusyBox4 is running. If I want, I can stop. Docker stop BusyBox4. Okay. This will stop the container, but not remove it completely. Okay. You see, it has stopped, but it is not gone completely. Data is still there. And that is the reason we are able to see our data here. Docker here. This is conceptual, everyone. Okay, so please try to understand. Okay. When the container was in our images, this was not running. These are not running. They are just the blueprint. Okay. This is just like the ready-made thing, but not being served. Okay. For example, you can say that, okay, it is the cake ready inside the refrigerator. It is the cake. Okay. When you start eating it, then you see this Docker PS. You are eating this cake, but cake is always there, ready to be eaten. Okay. Now you say that, okay, I don't want to eat it any further. So you can write Docker stop BusyBox4. Sorry, we have already stopped BusyBox3. Okay. So you can see Docker PS. It is running right now. You see, it has stopped. It is not running. But I stopped eating cake. That doesn't mean cake is not there anymore. I can see Docker PS -a. My cake is here. If I want to eat again, I can write Docker start. That is the difference between run and start. Run is first time when you don't have the cake itself in the refrigerator. But when you have it here, you can always serve again. So you can write Docker start and you give the name BusyBox3. Make sense, everyone? Please let me know what you did not understand. Okay. If I want to go inside, how do I go it? Anyone tell me, how do I go inside this container?
Docker exec.
Very good.
-IT.
-IT.
Very good.
And the name.
Okay. Doesn't run.
SH, right? At
Sh.
the end.
Exactly, because sh is the shell we are running. Actually, just the command. Any command you give, it will run. Okay. If it is Ubuntu based, you can run actually bash. This is a very slimmed down version, so it has only sh. And you see your file is here, everyone.
So what are some other example commands you could run besides sh?
You can run anything. Oh, here, beside the exec, what you can run?
Oh no, besides sh.
Oh,
Besides,
you can run any command. You can write ls. It will show you what is inside the container. You can actually create a file here. Touch.
You can install things as well. I mean, you
Yeah.
could start installing things just like you would an EC2 instance. Start thinking of these as like little instances inside of your instance.
Any bash command you can run here. For example, we created this file here, right? You can actually go inside and see the file. I can remove actually this file. Make sense, everyone? Now I want to stop it. I can write Docker stop, and I will give BusyBox 3. It will stop BusyBox for me. Now my data is not gone, but my data is here. Now let's say you say, you know what, I don't want it at all. I don't want to keep it. Command to remove this is docker rm and the container name. This will remove completely. Okay, let's say I don't want to keep BusyBox3. You can give name, or you can even give the ID, container ID, or you can even give just the first 3 letters of the ID. It will remove it as well. First 3 letters, okay? Any questions? Let's say I want to remove this one. You can see that is gone. So I want to remove this one. You can write Docker rm this. But you may say, I have so many of them. How do I remove all of them at once? So there is a command, tricky command for that. Okay, any questions so far? Because I'm going to remove everything now. The command is this: docker rm docker ps -8. You run this command I'm sending on chat, it will remove everything. What it does is it finds the ID and then it runs rm on every ID. This is the command that it does. Everything is gone. Make sense, everyone? Any question? Okay, so that is the complete lesson we had so far here. Any question? Now we will go ahead and talk about Docker Hub. Okay, we will go and create an account in Docker Hub. We'll pull images from Docker Hub. We'll then work with Docker Hub. Okay, but before that, we are over an hour and almost 15-20 minutes. So we will go for a good 15 minutes break. Returning 15 minutes, we will then talk about Docker Hub. Sounds good, everyone? All right, see you in. Okay, so what we will be doing now is we will be learning about Docker Hub. Okay, so everyone, please open this link. Okay, this Docker Hub. You just simply do Google search and you will land on this page. Okay, this is the page where all the Docker images are stored. Okay, so I encourage everyone to go ahead and create your account. Okay, if you do not have account, if you have, that is fine. Then you can click on sign up. You can continue with Google, GitHub, or you can create your own account. Okay. If you create your account, you will come to a page like this. And whatever the username you have used, just use the same username and password, and you can log in into your own repository. Okay. I will give you 5 minutes of time. Not 5 minutes, I think you don't need, but you 2 minutes of time. You can just go ahead and create your account here. Okay, please take 2 minutes of time and please create your account if you don't have already. Okay, wait a minute more, 1 or 2 minutes if you want to take. All right, so if you have created an account, this is the place where you can store all your images. Okay, so what we will be doing is we will be creating images and we will be storing our images here. Okay. But that lesson we will be doing probably later. Okay. On this day, Docker file. On this day, you will be learning about that. Okay. Here. Okay. But meanwhile, we will continue. Okay. So what we will be doing is we will now be pulling up images. So you can probably search here dojo jump, let's say. Okay. You can search for dojo jump and you can see this is one of my students who has created this. And this is my repo. You can search here. Okay. This is the place where I have uploaded my images. So these images are public. Okay. This is the public ready to use blueprint. Okay. Of the actual container which can run. Okay. So what we will be doing is we will be running this. So you can run Docker pull and you can pull this image I have uploaded. So you can see this is version number 1.0.0. Okay. And in this version, okay. So you can write Docker pull. Let's see Docker PS, there is nothing. Okay. Docker images. And you can see these large number of images are here, but it doesn't have my image. So what I will do is Docker pull my name followed by a repo name and tag. Okay. This is the normal format of a Docker image. You have the username who has created this image. Okay. Then you have dojo jump, the actual repository name. So the way you have GitHub, you have repositories, you have Docker and Docker. You have versions and branches there. You also have version here that is called tag. That is called 1.0.0. That is the normal one. Okay. If you want to create another, you can actually create another. If you do this, you will see this, that this is pulling the image from Docker Hub. Everyone, please run this command. Okay, so you can now see if I run Docker images, you will see this is the image available here. I had created it long back, so you can see 2 years ago. Okay, this is the tag name. This is the image ID. Sounds good, everyone? Now there is an interesting thing I'm going to show you. This image is actually based on Nginx. Okay. So I think I have that lesson here. Yeah, I have that lesson here. Okay. Okay. So there is an interesting thing I want to show you. And okay, and that concept is called port binding. Okay. So what happens is whenever you run any container, okay, depending on the way it has been created, it runs on a particular port if the port has been exposed. So Nginx normally runs on port 80. Okay. But you know, we people want to see our application running. But the way how Nginx or Docker works is it creates its own environment. Okay. where it runs the application. Okay, so you can see here that this Nginx image that we are going to run, it internally runs on port 80. That runs inside the Docker container. Docker is virtualized, it's inside, it's enclosed environment. If you want to access it outside, you have to open the port actually. And this is the concept of port binding. You bind the internal Docker port to external system port. Everyone following with me? Okay, so this is the port binding that we are trying to do here. Okay, so if we do this one, the same thing we are doing here. What we are doing here is internal port is also Nginx based port 80. Outside also we want to run on port 80. So you can simply copy this command, okay, and run this, and this will start your application on port 80 internally and also externally port 80. If I search for localhost, you will see my application running. So your Dojo gem is here again, but it is now running on Docker. Okay, everyone? So please let me know if you were able to get it working. 1000 point. Okay, how does it work? I did not install Nginx. I did not do systemctls start Nginx. I did not do any of this. I simply did docker run port and the image name. Let me know if you have any question.
Just a real quick, the lesson has 8080:80. Is what you have shorthand?
I will come to it. Yeah. So try what you can. The way how I was explaining is, this is the internal port. This port you cannot change. This port depends how the image was built. We will learn that later, okay? In Docker file, we will learn that. But this port you can control. You want to run on port 80? You can run. Let's say you don't want to run on port 80. You want to run on port 88. No problem. You run it. Your application will not run on port 80, but it will run on port.
Okay. Thank you. Just me and the short bus catching up. Thank you.
And yes, and your lovely dojo is here. Yeah, so Chad is just saying port mapping still confuses me. But yeah, definitely, but this is very beautiful concept as well, right? See, the beauty is you are running here, you can run one more here. 8080, let's say I want to run 8081. Let's say I want to run a 89,000, let's say. Everywhere your application is running. Everywhere your application is running. How many you want to run? You can run those many. You just have to change the port.
The game's distracting because it's so easy to play.
True. Chad wants to say something about port mapping. It seems Chad has some good experience. Chad, do you want to say some experience?
Oh, I mean, I just always, it's something I always have to slow down, and then it gets more complex as you, because right now you're running this on your local host, right, Chandra?
Yeah.
And so when you start launching Docker inside of, say, instances, then you have to start getting into making sure your right ports are open, right? So because you're going to open up ports, and it's something for sure, like, you should probably be a little bit confused by. I mean, I don't know. It's not the most simple concept, and it will get more confusing. So just ask when you get there.
100%. No, totally. I totally agree with you. You know, these concepts, in fact, become more confusing when you start applying that with Docker Compose, and then super confusing becomes when you start using Kubernetes. So Kubernetes has like concept of service. So I think, yeah, there's a bit of glitch in this. Yeah. Okay. Did everyone understand this concept, this port mapping thing?
I will say one more thing. The best way to learn is kind of like what you just did, where you started opening a bunch of different ports and getting it serving on different ports and then going and looking at it. And then just like, that's kind of the way you have to learn. And then when you start using Nginx, and because you'll start doing reverse proxying. And if anybody's interested in like ever doing HTTPS, like actually being able to serve your own applications over a secure protocol, you're going to want to learn all the stuff in Nginx. Like you're just going to want to learn it, or you won't even be able to do your own, termination. And it's very helpful, super, super helpful. Once you learn it, it's like extremely helpful to use Nginx.
Yes, I definitely want to learn it well.
I could not agree more. 100%, Chad. Right. So, as Chad was saying, the best way is that you just experiment with it, because, it's just a container. Even if it does not work or something you have broken, you can just do Docker RM, remove the container and run again. No attachment, no harm, right? So it's a very safe way to experiment and learn. Yeah, so you can see these are the 3 images running. Now, if I want to write a stop, I can write Docker stop. I can stop all of this. Okay, and I can remove all of this. See, as I was telling, stopping does not remove it. Okay, so even if I write Docker ps -a, my images are here. Docker rm, I can use this tree command. This will just remove all of that. Okay, everyone. So this is the way how you can use Docker port mapping. Okay. So now we have learned how easy it is to use Docker. Let's quickly go through and understand the concepts more. So the problem which initially was that the developers used to build the code and IT operations used to run the code, okay? That process is now simplified using Docker, okay? You can see whether you want to run on bare metal or on Linux or Windows, anywhere you want to run, Docker will directly help you with that deployment. Okay, so developers are free to create any code at any machine with any package. IT operations, they just know that I will have a Docker image. I just want to deploy that Docker image. Okay, so this myth of that cloud and old infrastructure application does not work on new infrastructure, everything is gone with just Docker container. You want to run traditional app, container will help. You want to run agile app, you want to run microservices, container will help you right away. Okay, so we all are learning Docker, and you can appreciate how beautiful it is. We should learn a bit of quick history as well. This started in 2004, okay? And in 2008, actually what happened due to this economic slowdown all over the world, okay? There was a huge down time in the stock market and everything. The stock market was broken. IT boom was just exploding. This company, Docker, had gotten bankrupt. They had no money. They were looking through all the applications they have, and they found that they have built one application which can be useful for public. They were an IT services company, and they saw that, okay, we can make it open source and see how people like it. And the day they open sourced it, it became very popular. And after a bit of work in 2013, they made it open source. And once it was open source, it became very, very popular. Okay. Today, Docker is one of the most celebrated, one of the most starred and liked project on internet. Okay. So this is the history of Docker that we quickly talked about. If you want to know more, please go and read about it. Okay. It has very interesting story. Okay. You can read about interesting story of Docker. Okay. So there is, yeah, what led to invention and all. You can see that containerization did exist before. So it's not like Docker has brought the concept of containerization. That is important to know. Containerization was even earlier, but that was through LXC. There is some concept in Linux, okay? Linux containerization. But it was so complicated that only the large corporations like Google were able to use containerization. Docker just made it super easy. And you can see one of their founding team in Docker in one of the conference, and Docker was like super nice success. Within 4 years, they were like 14 million Docker hosts were running. Almost 900K applications were on Docker. So it became kind of, you can say, overnight success. Today, Docker is used in almost every large organization. Anything that you use is running probably inside a Docker container, okay? Except this Bitcoin thing and all that I know, they don't run in Docker, and except some banking related thing and all, almost all of the large portion of the internet is new age applications run on Docker. That's what the reason I say new age. That means only 10% of the new applications are new age. Actually, they run on Docker. Almost, I believe 60-70% or 80% would still be running on bare metal probably. So this is the reason Ansible is still important. Ansible is not something that you can ignore. Any questions? So these are some of the use cases, like ADP is using, GSA is using, this university is using, I believe, okay, Cornell University is. They all use Docker for agility, security, and advanced applications. Okay, Docker brings improvement in terms of software release, in terms of reducing the mean time to delivery. It reduces the server cost. It eliminates the issue of it works on my machine. There is a very popular meme on this, that before DevOps, okay, I mean before Docker actually, people used to say it works on my machine, but after DevOps, after Docker has come, it works on your container. Okay, on everyone's machine can work. Okay, so this is kind of the Docker family. So Docker has two versions: the free version, the community version we use. It has enterprise version, which is paid product. Okay. Do you want me to talk about this, or you feel you can probably follow this? Because otherwise I will just focus on the hands-on part otherwise.
I think I can actually follow it and read, the history and all that. I'd rather focus on process.
Okay, perfect. Yeah.
If I'm understanding your question correctly.
Yeah, so I just meant to say that I will then quickly just run through this slide. Okay, I will not be talking about this. You can probably.
And don't let me speak for the whole class. So if any of you disagree, please speak up.
Okay, I think
I agree with her.
Yeah, I think pretty much I also feel the same way, that you can, these are like now obvious concept, okay, that you can probably learn. So this is how the machines are. You have physical machine, and you have the OS and the application. An important part here to know is the difference between VM and containerization. Okay, so the concept here is that the virtual machine, this is something that you definitely I will talk about. But so you have physical machine and you have the host operating system. Let's say you have Windows machine. So normally what happens is that on these machines, they have a software, a layer called hypervisor. Hypervisor actually will help you to run multiple other guest operating systems, virtual machines on the same operating system. Okay, so you have OS, you have hypervisor, and then you have virtual machines. In the virtual machines, then you have another operating system and you can run application as you want. Okay, this is how the VMs look like. Okay, And in EC2 and all, in Azure or Google Cloud, digital ocean, everywhere what you run is, that is a virtual machine. Okay. So these are the limitations of virtual machines. I believe you already know it, that you waste the space that is not being used. Okay. And this is where Docker comes in picture. It helps you with to maintain the dependency, to maintain the consistent environment, and you can easily have a portability. You can run here on another machine as well. And in all of these use cases, Docker is very helpful. Okay. So we already talked about it. Okay. What is container? Okay. It is a standardized package for any application that you can share with somebody else. We already talked about it, that Docker will virtualize. It kind of works as the gateway for you to use the kernel directly. You don't have to have kernel here. There is a quick table here which compares Docker with virtual machine, and virtual machines have full OS. They take longer time to build and run. Okay. And they are heavy. Okay. They are less portable. These are the limitations with virtual machine, which Docker completely removes. Okay. So this is how the applications, containers and virtual machines actually generally work together. Okay. So if you want to, let's say you want to run multiple OS on the same server, then only VMs will help you. Okay. So these are the key benefits of using Docker. Speed, it takes very less time because there is no kernel. You can easily port one application from one server to another server. You can run on another server, and it is very efficient because it's very lightweight. It takes very less amount of time. Okay. We have talked about images. We talked about container. We'll talk about engine and all. So this is how the Docker architecture looks like. Okay. This is the daemon. On top of that, you have the actual daemon, the core application it is. There you have APIs where you can interact, and these are the clients. You make requests through these clients to the daemon. Okay. Again, I may feel I'm rushing, okay, because I'm quickly running through the PPTs, but I know that you can actually follow this yourself. This is what almost everyone believes, so I am just going through it. Okay, you don't need to worry much about this architecture, how it works. I have just, so this slide I created for a very advanced level of lesson I was teaching. Okay, there we did go inside all of this in details, what is run C and all, which you don't need, so probably you don't need to worry much about it, but I will send you this so that you can follow yourself, by the way. So this is how the CLI is. There is a daemon, then inside daemon, actually this engine that you are looking at, there is, this is called containerd. This is the container runtime, the daemon, and inside that you have shim. Okay, then you have the runc, the runtime container. That inside have the containers, and that inside has this thing, and that has like this container, and it here, this is where it uses the Linux capability of containerization. All of the process inside will have their own network, they will have their own process IDs, they will have own process intercommunication, they'll have own user management. Okay, so they have, there is something called concept of namespace, which keeps the application separate, and control groups, which puts a control on what application can access what other data. Okay, so that is a very quick run through. We just did this. You will now learn these things probably in the next class. Okay, no, we did this already. Sorry, we just did this class already. Okay, and this process, container deployment and all, yeah, this probably will be done after a Docker file and all will be probably taught by Reno. Okay. Meanwhile, yeah, this is one of the slide on alternatives, as Troy was probably mentioning. And Docker is not the only thing which can help you with containerization. Even Podman is there, LXD is there. So there are these three different tools are there. Probably they all have their own pros and cons. Okay. For example, Podman, it runs in rootless mode, which people like, because you don't have to give the root permission to Docker. But Docker needs root permission. So that is benefit with Podman. Okay. security is moderate in this. Podman has very high security standards, right? So these are some of the difference that all of this provides. You can definitely go and probably explore more. So Docker alternatives are LXC and Podman. Okay. We talked about this already, that we use the free version. There is a paid version already on this. Okay. So, but you don't need to worry much about it. Okay. Sounds good, everyone. Any question?
So those slides that you were skipping over, specifically the DevOps slide that was right following the, are we hitting those on another lesson? Or
yeah, these lessons, these things will be actually followed by Reno actually. So it's not that any of this will be missed. All of this will be taught to you. Okay.
Okay, wonderful. Thank you.
Yeah, this will be taught, this will be taught, networking will be taught, then volume will be taught. All of this will be taught to you. Okay.
Perfect. All right, thank you.
Oh, sure. If you have a look on this, so the way how it is like, we have the whole lesson is on planned on this. Okay, so don't need to worry about it. I'm having a look on all of this myself as well. Don't worry. All right. Okay. So this what we finished. That was on Docker. Okay. And then now I think we already did this lesson already. Okay. The port mapping. Though this is a new different lesson on this. Okay. So you can please do that. Now let's talk a bit about assignment. Okay, because I have a meeting coming in probably 20 minutes, 30 minutes, I think. Yeah, 25 minutes. So these are the assignments you have. Okay. So your job is, this is the first one, Docker introduction and setup. Okay, you have to run a hello world Docker image. That is the assignment number 1. I feel very easy. Second one is 2048 application. Okay. So what you have to do is, I won't ask you to actually go and create this because we have not taught you Docker file still. But what you can do is you can use this particular image. So this is the image you can use to run the application 2048. What is this application? This is this 2048 game app, everyone. This game. I'm not sure if you have played this or not. This is a very popular game, 2048. Your aim is to make 2048 probably in the least attempts and maximum score, I believe. Okay. Then this is some of the for the reading material you have. Then this is another reading material you have. I think I can probably give 1 or 2 more assignment to you. And one of this assignment is this, that you have to run the game using 2048. Another assignment that I will give you is you have to use Nginx. I'll give it to you. And you have to use Nginx and you have to run the application yourself. Okay. So that will be all for before noon session, everyone. Okay. Let me know, okay, if you have any question right now.
I have a quick one, Chandra, just about the challenges. Are they all going to be, I haven't looked too closely, I remember these, but are all these single containers going to be all single container builds? I just want to know when I'm helping people out. I thought there was Nginx. I didn't know if the Nginx is going to be a separate container than the application, or is it all going to be served?
Thank you, Chad. I think let's talk about assignment, in fact. Okay. So see, assignment number 1 is very easy. You just have to run the hello world image. Where will you find this image? How to run it? You have to figure out. Okay. Assignment number 2. Okay. You have to do the port mapping. You have to launch this container using this image 2048. Okay. So it will be using actually Nginx on Docker. Okay. So Chad, you are right. The first thing you can do is that you can directly use the image I have given. Next thing what you can do is you can run like this: Docker run -it itd nginx. Okay, and you can see nginx is running, and now you can go here and you can write docker exec -it, and you can go here and you can see that inside this directory, usr share and cd nginx cd html. This is where your HTML file is. For example, see this index.html. What you have to do is you have to bring this code, this application, and inside this, and you have to run your own application to 0 it. Okay, did you feel what I'm trying to say?
Yeah, definitely. I think that should help everybody. And then this is definitely just a single container application. Nginx is going to be serving the entire game, the front end. And yeah, that's what I was just curious to make sure. But you guys should ask more questions if you guys have some questions.
100%. Yeah. So basically, chat, we are not asking them to build an image because we have not taught them Docker file yet. So only option is they can go inside and play around the file inside.
Maybe one thing real quick you can show there, because I think you're running that Nginx. Did you run that image? Yeah, that container's running.
Yeah,
I was going to say you can show them how it's just going to be serving the Nginx. If you could show maybe on the local host how you're just going to be serving the base Nginx HTML, that might bring it home for some people.
Okay, so see, the way how this works is that you run Docker, okay, and you write for, let's say, port 8080 colon port 80, okay, and you run here, okay, see Docker ps, and this one I will press stop. I was just running, and I can see Docker ps. I will go inside, okay, Docker exec D58 and bash. And right now, if you see port 8080, if I open port 8080, okay, this is the Nginx running right now, right? What you have to do is you have to go to this directory, usr share Nginx HTML, and you have to change this file so that you serve the 2048 application here. Make sense, everyone? Thank you. This is your assignment number 3, and that is on, you have to read about this and you have to kind of study all of this based on what we already talked. You have to just study this in details. And 4th one is you have to prepare a report on comparison with Docker and virtual machine. Okay. If you want to want me to give you another assignment, I will tell you that you have to run MySQL on Docker. That is a final assignment. If you have time left, your job is to run MySQL using Docker. All right, everyone. Okay, any questions?
None right now, Chandra, but if I have any, I'll reach out.
Okay, perfect. Thank you. All right, so this is all in the before noon session, everyone. I know that we don't have a lot of time in our hands. So in afternoon, I think if everyone agrees, I would continue and probably teach Docker volume. Or if you want, then let me see how much time and all we have. A bit of flexibility this time. Okay, we'll see. If you want, we can actually start with a new lesson. Otherwise, we can work on the assignment. Okay. We will return at 1, right? We'll be going for lunch now, right? we go at for 11:30. See, if you want to go early, you can go early. That's no problem. Probably we can return by 1. Okay. 1 sounds good, or do you want to come early, 12:30? Anything, I'm fine with anything.
I'm flexible.
Okay, let's keep it 1 as always then. Yeah. Okay, so at 1 we will return and we'll work on assignment. If you want, we can start a new lesson. And the new lesson will be on Docker volume. Okay. All right.
Good lesson. Good tempo. Good lesson, Chandra.
Thank you. Yeah.